Hey champions, today we're going to be having a little look at negative indices. Alright, we're going to start off here with a pretty easy example. So let's say we've got a to the power 3 divided by a to the power 5. So pretty straightforward index law number 2 problem. So we've got the same base there, we're dividing, so we can simplify by taking the powers away. But what's a little bit weird about this one is if we do a to the power 3 take away 5, it leaves us with a to the power negative 2. It's a bit weird, we've got a negative power in our answer just there. What's going on here? So I'm going to rewrite this. So a to the power 3, I'll write as a multiplied by itself 3 times. I'm going to divide that by a to the power 5. So a divided by itself 5 times, like this. Okay, now I can cancel off a few bits here. A over A cancels to 1, A over A cancels to 1 as well, A over A cancels to 1 also. So what we're left with there, after our cancel party, is 1 over A times A, or 1 over A to the power 2. So what we've shown there, with our little experiment, is if we've got an answer of A to the power negative 2, it's the same as saying 1 over A squared, which is kind of interesting. So that brings us to the focus for today, which is negative indices. So we can actually generalize this by saying if we've got a particular base and it's raised to a negative power, so a to the power negative m, we can rewrite that as 1 over the same base raised to the same power, but positive. So this is just a nice little shortcut generalization that we use when simplifying indices. We can also go the other way around as well. If we have 1 over a base to a negative power, we can rewrite that as that same base to a positive power. And if it helps you to think about that as being over 1, kind of shows that if you've got something to a negative power, we want to either take it from the denominator and put it up on the numerator, or if it's negative in the numerator, we want to make it positive on the denominator. And the reason that that's important is a lot of these index laws questions will say, express your answer with positive indices. So it's really important that you can take a negative power and then plonk it in the right place. Okay, I'm going to start with a few pretty straightforward examples. So up in the top left here, we've got express the following using positive indices. So c to the power negative 4. So we just make that 1 over the same base raised to the same power but positive. So expressing that using positive indices is just 1 over c to the power 4. And that's it. The next one, we've got 4 multiplied by a to the power negative 2 multiplied by b to the power 3. For this one, we're going to leave all of our positive powers in the numerator because that's where they belong, and it's only that a to the power negative 2 that we're going to shift. We're going to make that power positive and plonk it in the denominator, just like that. The next one, we've got a to the power negative 2 in the denominator, so we're going to make it positive and chuck it in the numerator. So these aren't especially difficult once you get the hang of them, but they do need a bit of practice to get your head around them. The last one just here, D, this one is a bit of a combination sort of problem. So first we've got to use index law 3/4 to get rid of these brackets. So we've got 4 to the power 1, because remember here in maths we've got an invisible 1. If it's a number or a base to no power, it just means to the power 1. So it becomes 4 to the power 1 multiplied by 3, which is 4 to the power 3. A to the power 2 times 3, which is a to the power 6. Over a to the power 4 times 3, which is a to the power 12. Okay, so here, if we used index law number 2 to simplify this, we'd have a to the power 6 take away 12, which would be a to the power negative 6, which we would then put into the denominator because it's a negative. What I'd probably do is say, well, I'm going to cancel these off. I've got 6 in the numerator. I'm going to get rid of 6 in the denominator. Still gives me a to the power 6 in the denominator. 4 to the power 3, I'll write 60 as 64 just for fun, over a to the power 6. Okay, so that's a bit of a combination one. It just shows that you can cancel down as well as cancelling upwards. Okay, now it's time for a couple of spicier questions. Okay, so these ones, this first one here, so we're going to simplify the following using positive indices. So we've got a bit of a combination question here. We've got a pair of fractions being multiplied together. We've got a whole fraction within a bracket raised to a negative power. We've got a numerator in a bracket raised to a power as well. So well, the first thing you want to do when you see something like this is start by getting rid of any brackets that are there. So on the left-hand side, a to the power negative 2 multiplied by 3 is a to the power negative 6. Multiply that by b to the power 3. And then I'm pretty much just going to have to copy the next one down. So please bear with me while I do that. Okay, now on the right-hand side, we've got to apply that power negative 3 to everything that's in that fraction. So multiply that through all the powers. A to the power negative 2 times negative 3 is a to the power positive 6 over b to the power negative 3 times 3, which is b to the power negative 9. Good one. Okay, there's a couple of different schools of thought as to what you do next here. I'd probably recommend just making everything positive. As when I say everything positive, I just mean your powers for this one. A negative number here would just be a negative number. So for me, I'm going to start by making my left-hand side indices positive. So b to the power 3 stays up there. 4, and then I'm going to multiply that by a to the power 1 as well. I'm going to use some arrows to actually show what I'm doing. I'm going to put my a to the power negative 1 there, my a to the power negative 6 down here. So on my numerator, I've got ab cubed over 4a to the power 6b to the power 2. There, once you get the hang of these, you could probably skip a little bit of that and like cancel it as you go. While you're getting the hang of it, I'd probably do it like this to, not necessarily save you time, but save you from errors, I would say, while you get the hang of it. Plus, you never know, you might be able to get rid of some of these as part of a cancel party. Anyway, so I've got b to the power negative 9. I've plonked that up here. Okay, now it is time for a cancel party. So now I've got a to the power 6. I'm going to cancel that with a to the power 6 here. Goodbye. I've got b to the power 3 over b to the power 2. So I'll use index law 2 to simplify that and make that b to the power 1. Okay, now I've got an a b to the power 9, and a 4 and a 1 left over. So I've not really much cleaning up to do. I've got a and b to the power 1 multiplied by b to the power 9. So if I use index law 1 for that, I'll get b to the power 10. And that's all over 4 times 1, which is just a plain old 4. Happy days. Okay, let's go to one that is slightly spicier. This one involves a little bit of division as well. So as well as making getting rid of our brackets and making everything positive, we'll need to deal with that division in the fraction as well. Okay, so like we did before, first job here is to get rid of both sets of brackets. So we've got 2 to the power 3. I'm just going to write that as 8. a to the power 3 times 3, which is 9. b to the power negative 2 times 3, which is b to the power negative 6. c to the power 3 times 3 is c to the power 9. Cool. Divide that by, and then bracket number 2. 3 to the power 2, I'm just going to write that as 9 straight up. a to the power negative 2 times 2 is a to the power negative 4. b to the power 3 times 2 is b to the power 6. And c to the power 2 times 2 is c to the power 4. Good one. All right, now I'm going to make everything positive again because I'm a positive person and that is what I wish to do. Okay, I'm going to plonk this b up here, this b to the power negative 6, and make it positive. So now I've got 8 a to the power 9, b to the power 6 over c to the power 9. Divide that by, and again, I'm going to make this one positive and plonk it down there. So now I've got 9 b to the power 6, a over a to the power 4, and c to the power 4. Okay, now I've got to do something a little bit funky because I've got a division with the fractions. The way that we divide fractions is to flip the second one and multiply. So my first job is just to straight up copy down the fraction that's on the left hand side. And now I'm going to multiply that by the reciprocal of the fraction on the right. So a to the power 4, c to the power 4, over 9b to the power 6. And now, everyone, it's time for another cancel party. So one that sticks out straight away is b to the power 6 cancels with b to the power 6. Goodbye. Okay, 8. No, this is where I'm going to do one more bit of cancelling. C to the power 4 divided by C to the power 9. Remember, if that stayed in the numerator, it would be 4, take away 9, which would be C to the power negative 5, which is going to end up being C to the power 5 in the denominator. So I've done that a little bit more quickly. And then I can use index law 1 to combine a to the power 9 and a to the power 4. So my answer is going to be 8, a to the power 13. Did I say that right a second ago? A to the power 9 times a to the power 4 is a to the power 13. I feel like I've just said that wrongly, but that's okay. And now I'm going to divide that by 9 multiplied by c to the power 5. And with index laws, we treat regular numbers like regular numbers. Just happens that 8 divided by 9 we can't make any more simple than that, so we just leave it. And we obviously can't cancel off a to the power 13 and c to the power 5 because they're different bases, champignons. Okay, that's all for today. Thanks heaps.